Hi, my name is Dave Smith, and today I'd like to introduce you to the TMF8828X-SHIELD board. Today we're going to be using an Arduino UNO and our TMF8828X-SHIELD board, along with our new Arduino drivers that support the TMF8828X time-of-flight sensors. Now, within the box for the 8828X-SHIELD, we also include 4 air gap spacers of different thicknesses and 4 cover glass samples, also different thicknesses. This allows you to optimize the optical stack for the environment that you're operating in. We also provide some tools that allow you to check the crosstalk and make sure that it's within the guidelines specified within our optical design guide. So now that we've connected the two boards together, and in this case I used a 0.5mm cover glass and a 0.35mm air gap spacer. We plug that into our laptop, and that's our hardware setup complete. We need 2 pieces of software to make this system work. The first is the Arduino IDE, or Integrated Development Environment. If you don't already have this installed, you can go to arduino.cc, click on Software, and then you can either use the online web editor, or you can download the relevant IDE for the platform you're going to be using. In this case, I'm using Windows, and I already have the latest version of the IDE installed. The second piece of software is the driver and the Arduino example code. You can download those from ams.com/TMF8821. This page includes the datasheet, user guide, communication guide, optical design guide, and all of the necessary documents that you're going to need to get working with this part. If you click on Tools and Resources, scroll to the bottom of the page, you can then download the Arduino driver straight from here. Now, you can take this file and extract it into your main Arduino project folder. I've already done that, and so here we have our Arduino folder with our version 17 of the driver. If I click on that, you can see 3 folders within here. The first contains a utility to take an Intel hex record and convert it to a raw hex file that our application can decode. The second folder, the Python folder, this contains a number of Python scripts that allow you to exercise the commands of the Arduino, log data from the sensor, check the crosstalk for each zone. And then the third folder, this is where our project files are stored. The README file is a really useful resource that's going to talk you through the installation and operation of this example code, and also the Python files. In this case, let's go into our application folder. Here you see a number of different files. This example has been developed in a way that it will allow you to take this code, the core C++ files and header files, and port those to your own platform once you move beyond the Arduino environment. But if we double click on our INO, which is our Arduino sketch, this is going to open up our IDE. And once it does, here we see the sketch. In this case, it's detected the Arduino UNO on port 20. Sometimes this won't happen. Sometimes you may have to go into the device manager and locate which COM port it's on. If you're using a different board other than the Arduino, you may also have to install some drivers through the board library, the board manager. But here we're configured correctly. So let's hit the compile and upload button. What this is doing is taking these files, pulling all of that information together and combining them into a single file that is then downloaded to the Arduino hardware. And this is what we're going to execute. This is our main application. So now that that's downloaded, if I drag this window up a little bit, you can see we've now downloaded the code. If we open up the serial monitor here, now once it's connected, the Arduino is going to stream a list of commands that it will recognize that are related to the sensor. You can always pull this help menu up again simply by hitting H and enter. Here you see that the device is currently disabled, so the first thing that we need to do before taking any measurements is enable our device. This raises the enable pin, hardware pin, and it also downloads a little firmware patch with the latest application code onto the microcontroller within the sensor. So now our device has moved from disabled to stopped. So the part is active, but it's not taking measurements. So let's take some measurements. By pressing N and enter, we now see lots of data streaming. See values changing. So let me stop that. So let's now decode what these numbers mean. Reading from left to right, we see 65 is our I2C address for this device, OX41. 244, 245, 246. This is simply a sequential measurement count. The next number that you see here, 23, this is the temperature of the device in Celsius. The next number, in this case 9, moving up here, 17, 18, this is actually the number of returned measurements. This device is configured in a 3x3 or 9 zone, 9 micropixel configuration. It can also be operated in a 4x4, 3x6, 8x8, depending on the device and the configuration. Each one of those macropixels or zones can return 2 different distances, so detect 2 different objects. So here we're detecting 1 object per zone, and here we're detecting 2 objects per zone. Those 2 objects are the ceiling above me and my hand as I was moving in and out of the sensor's field of view. This long number is a timestamp, and then as we scroll across, the sequence is zone 1 distance, zone 1 confidence, zone 2 distance, zone 2 confidence, zone 3 distance, zone 3 confidence, and so on. The distance is in millimeters. Confidence is on a scale of 0 to 255. So we scroll along here, this gives us up to zone 9. And then as we move over here, these are actually the second objects that we're detecting. So this is the ceiling, a little over 2 meters above my head, or above the sensor, I should say. So distance of 2048, confidence 105. Zone 2, second object, 2008, confidence 199. Further down, you see we didn't have the second object. My hand wasn't in the field of view, so the ceiling was detected as the first object at around 2 meters. So I went through that very quickly. There's a lot of information there, but hopefully that gives you a useful introduction to the TMF882X-SHIELD and our new Arduino drivers and how to get up and running in a little over 5 minutes. Now I'm going to be creating a number of other videos that talk about crosstalk, talk about the optical stack-up, and how to move beyond these initial examples. But for now, thanks for watching.